So turn to page 98. And first of all, we're going to highlight this part of the question because it asks, where is something defined? And I guess the first thing I would say is if you read that question right now and we were having a quiz or a test, would you feel confident moving forward that you know what you're doing to solve this? I find that the word defined does that in this question. It's a new kind of question, and so we need to pay attention to when there's new words in questions. What this means it's really asking, where is it possible? Another way we could say this is, what is the domain? So when something's asking, where is something defined, it's asking, when does it work, when doesn't it work? And in fact, when asking where it is possible, I often ask the opposite question, when is it not possible? Now, when you started off your careers in mathematics, like kindergarten, you were like counting, and then you were adding and subtracting. And when you start off your careers in mathematics, everything seems possible. It's like you could count, and then it'd be like, I could keep going, and you could just go on forever, right? Did you ever attempt to see how high you could count? It's like a pastime of a little kid. Be like, ooh, I got up to 300 today. Then you don't want to stop because you could just pick it up the next day at 301. But it seems like if you, as a kid, you thought if you stopped here, you had, and you started again tomorrow, you'd have to start again at 1. And then it's like, you spent 3 hours on this counting. Hopefully you didn't spend that much time. But then, all of a sudden, you ran into the first thing that was not possible in math, and it came up in dividing. What are you not allowed to divide by? 0. Boom! Not allowed. Impossible. So you had your first experience of something not possible. Now we're in radicals and square roots and cube roots and fourth roots, and there's something not possible with square roots. What can you not square root? Negative numbers, right? Square roots of negatives are bad. So often when we're trying to figure out when things are possible, you're going to check positives and negatives. You're going to check 0. Those are often things that we use to check, to see if things are possible and not possible. As we get further on in math, you're going to figure out other things are not possible. Like, did you know you can't take the logarithm of a negative? And you're like, what's a logarithm? Next year. Next year you're going to learn about logarithms. But for right now, we just have dividing by 0 is not allowed. Square rooting negatives is not allowed. So we start off with A. It has a variable x. Ask yourself, can you find a value that is okay? Like, for example, would I be allowed to plug in 1? 1 squared would be 1. 1 times 27 would be 27. Are we allowed to square root 27? Absolutely. So 1 is good. Can you find a number that doesn't work?
Negative 1.
Negative 1. So try it. Negative 1 times negative 1 is?
Negative.
Careful. Negative 1 times negative 1.
Oh, times negative 1 is
right, because it's squared, right? So first of all, at order of operations, I do that. Negative 1 times negative 1, which would become positive 1 times 27 is still positive. Negative 1 is fine as well. Is there any number you can find where it's not possible? No. So its domain, the list of values that are possible for A would be everything. And we we just say that x can belong to all the real numbers. There's never a value that's bad because it got squared. No matter what you plug in, you will get a positive number inside of that square root. And square rooting positives is okay. But when we get to b, now we have a fourth root, and just like square roots, any even root, you can't do a negative inside. And it's already a negative inside, so the idea is maybe it never works. Okay? So it could be that it's never defined. But can you find a value that works?
Anything negative?
Anything negative, because when you cube a negative would be negative, and then that negative times a negative will be positive, which is all of a sudden good. So if we want to say anything negative, how do we write that? Well, the x values would have to be less than, check 0. You put in 0, what do you get? 0 inside. What is the fourth root of 0? 0. You're allowed to square root 0, cube root 0, fourth root 0. So we have to have the equal sign included here that x can be less than or equal to 0. Well, I'm going to add a part c to this one. And we used x's. It doesn't have to be x's. Let's say the question was b plus 3. Okay. For this one, we're going to just make a list of a few things that are possible and not possible. And we're going to start with Grayson picking a volunteer. So the only person that's possible not to answer this question is you. You get to pick somebody else. Can you tell me something that works for B? Who are you going to pick?
I think Max.
Max. A value for B that works. 4. If you plugged in 4, 4 plus 3 is 7, you're allowed to square root 7. Now, Max, you're going to pick someone for a value that does not work. Grayson. Oh, touche. So pick a value for B so that this does not work. That it's not possible. So we have the square root of b plus 3. You're telling me a value that I put in here that when I simplify it, it's impossible and doesn't work. If I plug in 2, I'll get 2 plus 3, which is 5. And that's still okay because I can square root positive. But what can't I square root? Negative. So what possible value B would not work? I plug in -1. -1 plus 3 is 2. It still works. -4. That would be a good one. Because -4 plus 3 will be -1 inside that square root. And then that doesn't work. Okay, Grayson, get to pick another volunteer. Someone else tell me something that's possible. 9. Plug in 9. 9 plus 3 is 12. You still have a positive number in there. And Allie pick someone for the last one that's not possible. -5. -5 plus 3 would be -2. So when we think about what's possible and what's not possible, we really start to understand what's happening in the equation. Then when we go to say it's defined, it looks like they have to be positive numbers, it seems like. Can I just write b is greater than or equal to 0? No. What is the smallest number that you could plug in that still works? -3. Because -3 would make it 0, that still works. Anything less than -3, you'd have a negative inside your square root. So I just wanted to show that sometimes when we start thinking about what works and what doesn't work, it can help us realize a pattern and get us to see our answer there. Joe.
So it's any number that's less than -3?
-4 is not possible. -3.1 would not be possible. This says that the b values have to be bigger than or equal to -3. And so this -2.9 is fine. -3 is fine because that would make it 0. But any other negative lower than that would be a problem. So this is the idea of define. It comes up in grade 11, it comes up in grade 12, they talk about it. It's really asking about the domain, and it's asking about where things are possible and where they're not possible. So I'm going to get you to circle question number 6.